Chapter 1.12.2 Guide for Running Windows Containers in Kubernetes. Summary. Run Windows containers on Kubernetes with similar steps as Linux. Configuring the node and using kubectl are the same. Create an example deployment using a YAML file specifying a Windows node. Matching pods to nodes requires labels or taints. Capture logs using Log Monitor, manage identities with GMSA, and ensure correct OS node placements. Consider runtime class for simplicity. Guide for running Windows containers in Kubernetes. This guide explains how to manage Windows containers using Kubernetes, highlighting some unique Windows features. While Linux and Windows containers share similar deployment processes, it is crucial to note that Kubernetes commands such as kubectl remain the same for both systems. The document offers practical examples to help users begin working with Windows containers on Kubernetes effectively. Objectives. Set up Windows containers on a Windows node for deployment. Before you begin, ensure your Kubernetes cluster has a Windows Server Worker node. Getting started. Deploying a Windows workload. The provided code snippet shows a YAML configuration for a Kubernetes service and deployment for running a Windows container named Windows Web Server. Using the image, mcr.microsoft.com/windows/servercore:LTSC 2019. The container will run a PowerShell script to set up an HTTP listener on port 80 and serve a simple web page with caller count information. The deployment will be scheduled on nodes labeled with kubernetes.io/os:/windows. The code, kubectl get nodes, is used to retrieve information about the nodes in the Kubernetes cluster. This command will list all the nodes in the cluster along with their status and details such as operating system. It is a basic command to check the availability and status of the nodes in the cluster. The first line of code executes the deployment of the Windows Web Server using the configuration specified in the Win Web Server YAML file. The second line continuously watches and displays information about the pods in the cluster with additional details in wide format. First, create a manifest file named Win Web Server YAML to deploy a basic web server in a Windows container. This deployment directly exposes port 80 to the service without port mapping. Ensure all nodes are functioning properly before proceeding. Deploy the service and monitor pod status. Once both pods are in ready status, exit the monitoring command with Ctrl+C to confirm deployment. Use kubectl get pods to list these pods and ensure deployment success. Verify network communication. For node to pod, use curl on port 80 from the control node. For pod to pod, use kubectl exec to ping. For service to pod, use service IP. And for service discovery, use service DNS. Windows pods can access service IPs, but not Windows hosts due to networking limits. Observability. Logs are crucial for understanding workloads and resolving issues, especially when handling Windows containers, which differ from Linux ones in their logging mechanisms. They often log to event tracing for Windows, ETW, or application event logs. Microsoft's open-source Log Monitor tool helps monitor these logs by piping them to stdout, making them accessible via kubectl logs. Configuring container user. Windows containers offer flexibility by allowing different usernames for entry points and processes, customizable from default images. Additionally, group managed service accounts, GMSA, enhance workload identity management, providing automatic password and SPN management, while enabling access to Active Directory resources, leveraging delegated management across servers. Taints and tolerations. The code snippet above defines a node selector to target Windows nodes with a specific build version and adds a toleration for pods that require a specific operating system, Windows, to schedule on nodes with the no schedule effect. The code provided is a YAML manifest for defining a runtime class in Kubernetes specifically for Windows 2019. It includes specifications for the handler, scheduling based on node selectors, OS, architecture, and tolerations with an effect of no schedule for Windows OS. This code is a YAML file defining a Kubernetes deployment resource for a Windows container running an IIS web server. It specifies the container image, resources limits, and exposes port 80. It also includes a service resource of type load balancer to expose the IIS web server outside the cluster. To ensure Linux and Windows workloads run on the right nodes, users need to use taints and node selectors in Kubernetes. The aim is to maintain compatibility for existing Linux workloads. Each pod should have the spec.os.name set for the intended operating system. Linux, for Linux containers, and Windows, for Windows containers. Versions older than Kubernetes 1.24 may require enabling the Identify Pod OS feature. The scheduler does not consider spec.os.name during scheduling. Normal Kubernetes assigning methods should be used to ensure pods are placed on the correct operating system. Windows pods also need taints, tolerations for proper assignment. Kubernetes 1.31 nodes come with default labels. Kubernetes.io/os for OS and Kubernetes.io/arch for architecture. Use node selectors to avoid pods being scheduled on incompatible nodes, particularly crucial for Windows and Linux containers. Taints can prevent scheduling on Windows nodes unless tolerations are used. Modify kubelet during registration to automatically taint Windows nodes. For multi-version Windows setups, use labels like node.kubernetes.io/windows-build. Simplify taints and tolerations with runtime class. This enables encapsulation of settings, requiring pods to specify the appropriate runtime class name for the Windows options used.